I am going to explain the calculation of the turnaround time for the problem of CPU scheduling based on FCFS, in which we are going to consider both the CPU burst time and IO burst time. So first you need to understand the problem. There are 5 processes given. For each process, the arrival time is given along with the burst time 1, IO burst time and the second burst time. Here the idea is that normally when a process is given, it will be comprising of the total burst time. So we schedule the process for the actual total burst time, and at the end of it the process finishes and we will be able to note down the completion time of the process. But in this problem, the burst time is divided into 2 parts. The first part happens before the IO operation and the second happens after the IO operation. So we cannot schedule them together, we have to schedule them separately. So let us go by the FCFS strategy. As for the FCFS, the first process will be selected and it will run up to 3. The reason that it ends with at 3 is that the arrival time is 0 and the first burst time is 3. So we are able to complete the first burst time of A at time 3, but it is not over. It still need to execute for another 2 units of time, but that can be done only after it comes out of the IO operation. So we allow A to enter into IO operation and we anticipate that A will become available again after finishing the IO operation, which is nothing but 3 plus 3. So 3 is the current time, and from this time onwards A is going to enter into IO operation. So by 6 unit of time it will become available again for our execution. It's like a future time that A will be available, and when it comes again, we need to schedule it for the remaining 2 units of burst time. Only then A will complete. So right now A has partially completed execution and it is in the state of IO operation, and again it will become available at clock time 6. In this way we are now proceeding to select the next process, and B is the second process, and since A finished left the CPU at time 3, B enters the CPU at 3, and because of its burst time is 2, it is going to continue in the CPU up to 5. And once again we apply the same logic. So when B finishes its first burst time at time 5, it is going to start its IO operation. So 5 to 9, that is 5 plus 4, 9, till then it will be busy with IO operation. So again at time 9 we can expect B to be available for execution, and we are supposed to schedule it for 3 units of time to finish it. And the third process is C. We are going to schedule it up to 9, that is nothing but 5 plus 4. So B is finish time plus the burst time 1 of C, which means 9. And so here the IO burst time of C is 3. So 9 plus 3, that is 12. Up to 12 we won't be able to get C for execution. So from 12 onwards it will be available. So we note down that the new arrival time of C and also the pending burst time. Now at time 9 we need to choose the next process. So we have to look into all possibilities. In the second list we have the process of A, which is available from 6 onwards, and B also becomes available from 9 onwards, and in this list D is available. So D as well as E are also. So all the processes are waiting for CPU, and as for FCFS we need to choose the process with the lowest arrival time. So comparing A, B, D and E, D is having the lowest arrival time, so it is scheduled next. It runs up to 15. Again D is also going to get into the IO operation, and we can mark it as 17 as the new arrival time for D. And when D finishes first time execution, the It's the first burst time. The clock time is 15. At 15, again we have the choices of E, A, B as well as C. D is not yet available because its next arrival time is 17. Except D, other processes are available for execution. Again, going by the FCFS logic, we pick A as the next process because its arrival time is 6, whereas the arrival time of E is 7. So, A getting the chance of getting into the CPU, and at time 15, A enters into the CPU, which means that it will finish its total execution at 17. So, 15 plus its pending burst time added together, 17 is the final completion time of A, and it no longer needs to run in the CPU. It has totally completed. And likewise, we need to select the process, next process, and 17 is the current time. So, currently the clock time is 17, and at this time we need to look into the choices. See, by the time D also has reached into has become available, but we cannot select D and we have to select B because it's having E. So, comparing to B and E, E has the lowest arrival time. So, we need to select E as the next process. So, E starts execution from 17 and its burst time is 2. So, 17 plus 2, 19. Okay, so 19 is the completion, the completion time of the first burst time of E. And as usual, 19 plus 4, which is 13, is the 23 is the new arrival time of E. Now we need to select the next process. Right now we have finished the first time quantum of all the processes. So we just need to focus on the second table. We don't need to look into the first. In the second table, whichever pending process, we need to select it as per the order of their arrival time. So the next process happens to be B, and the current clock time is 19. So 19 plus 9, 28. No, 19 plus 3. Okay, so we need to add the burst time, not the arrival time. So 19 plus 3, 22, which is the final completion time of B. Likewise, we just continue and finish the process C. So 22 plus 1, 23 is the finish time of C, and then 23 plus 3, 26, and finally E finishes at 31. And this is the final answer we have obtained for all the processes, and based on the completion time, we can easily calculate the other values like turnaround time and wait time. So this is the way you need to calculate the answer for this question.